Hi, my name is JayanthSai. My CWI ID is 50318242. Today, I'm going to present a topic on operating systems for smartphones. So, in the earliest days, the operating systems only read punch cards. The technology then moved on to command line systems like Unix, which is an open source doppelganger, Linux, and DOS. In 1980s, visual operating systems began to dominate the marketplace with the Macintosh OS and visual versions of existing command line system like DOS, window following behind. Today, our smartphones have become very powerful computers with touchscreen, voice, stylus, and mini keypad inputs and sophisticated full color visual operating systems. These devices use a whole new set of operating systems, many associated with the established personal computer platforms. While computer operating systems are geared to larger screens and keyboard and mouse input, phone operating systems are suited to smaller screens and more direct methods of interaction. The open source movement is still going strong, with many smartphone operating systems built on the free accessible Linux system and many mobile operating systems that are themselves open source. So, if we see over the past decade, smartphones have taken the world by storm, and recently, these smartphones are having a significant impact on our lives and are in fact redefining the way we access the information and communicate with others as well. This is due to not only the hardware but the specialized software that these devices run, and most importantly, their operating systems. Just like PC can run on different operating systems like Windows, Linux, or different versions of the operating systems like Windows XP, Windows Vista, Windows 7. Also, likewise, the most smartphones can also run on different versions of the operating systems. They are made for and in exceptional cases. They might even be able to run operating systems they were not made for. However, an Android phone will only run on a version of Android, and while an iPhone will run only on a iOS version. Even though the functionality of an operating system used in computers and smartphones are same, there are some certain characteristics of a smartphone operating system which are different from the ones which are used in the computers. So at present, there are many mobile phones operating systems available in the market, but cell phones with Android OS have now become domestic product, which was once extravagant product. The reasons towards this change is attributed to varied functionality, ease of use and utility. There are a number of tasks performed on it like making calls, sending or receiving messages, listening to the music, online shopping, online booking, playing games. Also, some of the web browsing includes WhatsApp, Facebook, or app logs, etc., etc. Hence, a large amount of user-sensitive data is stored within the devices. Increased usage of smartphone has led towards higher concerns about security of user private data. Due to Android as an open source mobile platform, user can easily install third-party applications from markets and even from the some one of the unreliable sources. Android devices are a soft target for privacy intrusion. Whenever the user wants to install any application, firstly, it's the description and the application screenshots which provides an insight into its utility. The user reviews the description as well as a list of permission requests before its installation. Whenever the user wants to install any of the application, so the user reviews the description as well as the list of permission requests before its installation. As the type of rates of malicious attacks increases, the difficulty of examining in advance whether an app is malicious or not through its descriptions has increased manifolds. In this paper, I have received, reviewed, and examined various Android software stack and compared the smartphone operating systems like Android. So here are some of the characteristics of the mobile OS for smartphones. Those are very easy to use, and also they maintain data usage and organization, and also good app store. Also, they provide very good battery life, and they are very resource limited hardware, and it provides robustness. And the main characteristics of this mobile operating system over the smartphones is the user interface for limited user hardware. Also, the library support for this is very strong as well. if we see the categories of mobile operating systems, there are plenty of categories which are available nowadays, but some of the various categories of mobile OS include manufacturer-built proprietary operating systems, third-party proprietary operating systems, and free and open source operating systems as well. So here we can have a clear picture of the components of a mobile operating system. Here the main component we can say it's a kernel. So if you observe the two diagrams, we have monolithic kernel based operating system on one side and microkernel based operating system on the other side. So if you observe here in monolithic kernel, the application, the system call takes place, and then it goes to VFSs, and then IPC file system are there in the second layer, and then followed by the scheduler and virtual memory, and then the device drivers dispatcher will present at the very lower level of this format. If you see the microkernel based operating system, you can see the application, IPC, Unix server, device driver, rail server are together formed in one layer, followed by the basic LPC, virtual memory, and scheduling takes place. So yeah, if you see here, the user mode and kernel mode takes place between the two monolithic and microkernel based operating systems. There are plenty of mobile operating systems available in the market. Some of the popular mobile operating systems are like Android, Apple, Windows. You can see the popular ones. So in Android OS, the Android OS is the most common operating system among the mobile operating system. Furthermore, Google is the developer of Android. Moreover, it is an open source and free operating system. BudOS, Samsung is the launcher of this operating system. It came into the market in 2010. Moreover, it includes features like 3D graphics, application installation, multi-point, touch, etc. In BlackBerry OS, the developer of this operating system is Research in Motion. It was specifically designed for BlackBerry devices. Furthermore, it is useful for corporate users, very advanced way. So, Apple OS. After Android, it is one of the most popular OS. It is designed to run on Apple devices such as iPhones, iPad, tablets, etc. Moreover, like the Android devices have the Play Store for apps download. Likewise, Apple iOS contains the App Store. Also, it has a very strong security features when compared to the Android OS. So in Windows mobile operating system, the developer of this is Microsoft. It is basically designed for pocket PCs and smartphones. Moreover, it has the features of computer-based Windows OS and additional features for cell phones. Next, Symbian OS. Symbian Limited is the developer of these operating systems. Moreover, Nokia was the first to use this OS on its mobile phones. Furthermore, it provides high-level integration with communication. This OS is based on the Java language. Next, if you see the Harmony OS, it is the very latest OS. Moreover, Hawaii is the developer of the Harmony OS. It is specifically designed for the use in Internet of Things devices. Palm OS. If you see the Palm OS, the other name of it is Garnet OS. Furthermore, Palm Ltd is the developer which developed the OS for using personal digital assistants. So the iOS kernel. The iOS kernel of iOS is the XNU kernel. Mainly, the acronym stands for XNU is not Unix. According to Apple's official GitHub page, XNU is a hybrid kernel that combines the MASH kernel developed at Carnegie Mellon University with FreeBSD and C++ components for the drivers. The BSD subsystem part of the code is normally implemented as user space servers in microkernel systems. The MASH part is responsible for lower level work such as multitasking, protected memory, virtual memory management, and kernel debugging support, as well as console input outputs. If we see the layer here, the GUI layer, and then followed by the APIs, Cocoa, Carbon Core, application services, which includes Quartz, QuickTime, and the core services, which includes Core Foundation. And the main part here includes Core OS, for example, Darwin, and then followed by the system utilities, and then the main part of the OS, which is kernel, XNU, which is not Unix, and then BSD, which contains the file systems, networking, NKE, and POSIX. Finally, the MASH, which contains the input-output kit and drivers. So this is the main process actually we can observe. There are plenty of layers here. You can see the application framework layer, binder layer, and then Android system services and media server which have an audio linker camera service on one side, and system server which have a search service, activity manager, window manager, and other system services as well. Then followed by Hall, which has the camera hall, audio hall, graphics, and other HLs as well. So finally, the Linux kernel, which contains all drivers, say for example, camera driver, audio driver, display drivers, and other drivers as well. So here the process takes and goes on. The OS initially executes various processes so that the statements will execute and connect the application program to the hardware. Whenever a process executes, it uses memory, space, and other resources as well. A mobile process is a sequence of services which may last over a longer period of time and span several devices during its execution. The results of the process are the effects the initiator expects from it. In traditional mobile hardware, a process executes the application logic by explicitly assigning local or remote services to the process activities and by invoking them directly. In contrast to that, in our view, such application process may diffuse into the mobile middleware. They just form a stub which collects information from the user, assemble the process and its general conditions, and to pass the mobile process to the middleware. So here you can see the clear picture of the market share of each smartphone operating systems. So there are plenty of things like RIM, Google, Apple, and Microsoft, Palm, Symbian. So let us see the view. Like RIM, which occupies 32% market share, and Google, which occupies 29% market share, and Apple, which have 25%, and Microsoft, which have 8% of the market share. Palm includes 4% of the market share, and Symbian is the last one, which includes 2%. So yeah, here are some of the advantages we can see of the operating systems for smartphones. The app remains active in the background, and also booting is very good. And we can manage the input-output devices, and also we can perform multi-tasks at a single time. So it's basically a multitasking. So it provides a platform for other application programs as well. It manages the memory in a very good, efficient way. It also manages the system files. It provides security as well. And the interface between hardware and software is very much good in this. Also, there are some of the disadvantages includes app remains active in the background. So because of this, the battery becomes very low, and also the phone won't last for longer times. And also sometimes the operating system becomes slow and phone will get stuck also. In addition to this, the developers will be having very rough time here. So it provides very low specification, particularly for the smartphones, run slowly. So those are also very threat and defense from virus. So here are the references I have taken to collect the information and gather the information I have put in the entire presentation. So these references has helped me a lot. So thank you, Professor, for providing this opportunity and helping me in this subject to learn a lot. It's very much pleasure to learn under your guidance. Thank you.